The Robot Series, Season 2, Episode 2, Distance Detection Using Ultrasonic Sensor. Welcome back to another exciting episode of the Robot Series, where we learn, earn, build, and innovate. In this episode, we are diving deep into one of the most important components in robotics and automation, the ultrasonic sensor. Specifically, the HC-SR04 module.B. By the end of this episode, you'll not only understand how the ultrasonic sensor works, but also how to connect it with your Arduino board to detect distance and control and LED automatically, a foundational concept for intelligent robotics and smart automation. The HC-SR04 ultrasonic sensor is a distance measuring device that works using the principle of sound wave reflection, or what we call sonar. It sends out a burst of ultrasonic sound waves at a frequency of 40 kHz through its transmitter, and then listens for the echo through its receiver. The sensor measures the time interval between sending the sound wave and receiving the echo. Since sound travels at approximately 340 meters per second in air, this time difference can be used to calculate the distance between the sensor and an object. Here, the speed of sound, 0.0343 centimeters per microsecond, is multiplied by the time the sound takes to travel, and divided by 2 because the signal travels to the object and back. This gives us a precise distance reading, accurate to within about 3 millimeters for most conditions. Let's look at the technical details of the sensor pins. The HC-SR04 has 4 pins arranged from left to right. VCC, this is the power input pin, which requires a 5V DC supply from the Arduino board. TRIG, this is the trigger pin used to send the ultrasonic pulse. The Arduino sends a 10 microsecond high signal to this pin to generate the sound burst. Echo, this is the output pin that sends back a pulse width proportional to the time taken for the echo to return. GND, the ground connection shared with the Arduino's GND pin. The sensor consumes about 15 milliamperes of current during operation and has an effective range of 2 centimeters to 400 centimeters, or up to 4 meters. In our circuit, we connect the VCC pin of the ultrasonic sensor to the 5V output of the Arduino UNO and the GND to the Arduino's ground. The TRIG pin connects to digital pin 9 and the echo pin connects to digital pin 10. Next, we add an LED to indicate when an object is within a specific range. The anode, long leg, of the LED connects to digital pin 13 through a 220 ohm resistor, and the cathode, short leg, connects directly to the GND rail on the breadboard. This resistor is essential. It limits current through the LED to prevent burning it out. The resistor value can range from 220 to 330 ohms, depending on brightness preference. Now, let's talk briefly about what happens in the Arduino code behind the scenes. Inside our sketch, we start by declaring the TRIG, echo, and LED pins. We then set TRIG and LED as outputs, and echo as an input. To measure the distance, we send a 10 microsecond high pulse to the TRIG pin, wait for the echo pin to go high, use the pulse-in function to measure the time it stays high, then calculate the distance in centimeters using the formula. The serial monitor displays the real-time distance measured by the sensor. If the distance is less than 10 centimeters, the LED turns ON. Otherwise, it remains OFF. This logic allows the Arduino to respond dynamically to the sensor's input. Now let's see it in action. As you bring your hand closer to the sensor, notice the LED lights up. When you move your hand away, it turns off. This is a simple but powerful example of using distance sensing for automation. This same principle is used in parking assist systems, automatic water taps, obstacle avoidance robots, level monitoring systems, and industrial automation. By combining sensors like the HC-SR04 with microcontrollers, we create smart systems that interact intelligently with their environment. We learn how the HC-SR04 ultrasonic sensor sends and receives sound waves, how it measures distance accurately using time and sound speed, and how we can use that data to control outputs, in our case, and LED. This fundamental concept forms the backbone of autonomous robots and smart electronics. That wraps up today's episode, Distance Detection Using Ultrasonic Sensor, on the Robot Series. In our next episode, we'll push this concept further, combining ultrasonic sensing with buzzers and motors, so our systems can not only see the world, but also react to it. and subscribe to the Robot series for more hands-on tutorials that teach you how to learn, earn, build, and innovate. A like, share, and a turn on notifications so you never miss a build.